Hello AP Physics 1, it's Mr. Ng with a video to show you how to manage your numbers in your kinematics lab 1. This is the lab where we held little binder clips on a piece of yarn and we dropped them from a ladder. As you can see, we have a lot of stuff already set up. I already have my chart set up with time, displacement, velocity, and I put in borders so that you can copy and paste it into sheets nice and easy. If you don't know how to do that, all you got to do is go here, and then you just kind of add this little border, right? You could get rid of them all. They're gone. Here they are. Seems easy enough. Notice that I've already put in the acceleration, which is negative 9.88. Negative because gravity points down, right? And down is typically negative. And 9.88 because that's the constant. Some of you might choose to do negative 10. I'm not going to mind it. You do that. On top of that, I've already set up the time increments that many of you chose, which is 0.1, 0.2, 0.3, 0.4, 0.5. Completely fine. Let's put in some equations. The equation to find velocity is just equal to the acceleration times the time. Really easy. Boom. Right? I'm able to just do this very simple equation because acceleration is constant. If acceleration wasn't constant, I would need to find the average and then multiply that by time. That's how we're going to find average velocity. Seems easy enough. Now we're done. To find displacement, the equation is a little bit different. Velocity, really easy. Just acceleration times time, right, in that little column. Displacement, we'll need to find the average velocity. Look, the velocity is changing, right? It's changing at a constant rate, but it's not a constant velocity. It's changing. So to do that, we do equal to. We'll do 0, which is the initial velocity. We're always going to use 0. Oh, I don't need to put in C2. Let's just type in 0, but it's not going to change, right? The initial velocity for all of these was 0 because you were holding it still. Plus whatever velocity at that moment. And then we take that and we divide by 2. That's going to give us the average velocity at that moment. So that average velocity at that moment, we multiply that by the time. I need a little multiply sign. There you go. And then this is the displacement. The negative probably hoops you up because that's not what you saw in your little sheets. But just so you know, the displacement is going down, and we're assuming the displacement from where you are holding on to it with your fingers. So the displacement is from the release point, which is above the ground by, like, I don't know, however tall that was, like 8 feet or whatever. I don't know. Okay, so all I did was drag it down to continue the equation, and now I have my whole data table. If that was too fast for you, if you don't know how to do that, look at my cursor. I got the arrow, I got the hand, and I got the little cross. I grab the cross, I drag it down, and I'm done. Good. But wait, what if this is not the way that you set up your equations? What if this does not look like the way that you did it? Well, you probably did it this way. Let me show you the other way that you did it. Delete, delete, right? So you probably did the equation where displacement was equal to 1/2 0.5 times acceleration, right? Times this number squared. So to do that, I'm just going to multiply it by itself. Good. I'm going to need a little multiply sign here. Multiply. I don't know why I put parentheses. You don't need it. Boom. Same thing, right? It's the exact same number, right? And then for velocity, 0, same thing. The velocity is equal to this thing times this thing. Either equation works. You'll get the same number anyways. Good. Thanks for watching. If you want to learn how to graph it, watch my next video.